Okay, we're going to talk about average value theorem. Sometimes it's called average value theorem for integrals. Sometimes it's just called average value theorem. It is different from the mean value theorem, which is something that you learned early in calculus and was related to derivatives. Average value theorem is going to give me a formula to find the average value of a function. Before I get into that, I'm going to show you a couple spaces where knowing the average value of something makes a lot of sense. If you look at these two right here, this is speed from a bike ride, right? You know, a lot of times people want to know what's my average speed, because then you can like kind of determine how good of a ride you had or whatever. The other thing you could look at during a workout is you could look at a graph of heart rate, and then you could look at a graph of your average heart rate right there. So those are two spots where average values are things that we care about. So let's get into how we find the formula. If I were to draw a line, so this is where it hits A, and then B is right here. Okay, so say I had, I was looking at all these little values right here, I was looking at the height of f, and I were to take this height and 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 this height, and go through and take a whole bunch of heights of this function, and boom, get to there, and then find the average of all them. That would be about the average value of this function. I would argue that it would be pretty close to where that red line is. And what I want to convince you of is that if I were to find this area right here, the area of that red rectangle, maybe I highlighted it red. What I would argue is that that red area has to be the same as the area under the curve from A to B. So I'll highlight that area as well. Highlighted weird there where it overlapped, but this whole area, all this blue, would be equal to that red area. And I'll go back a little bit so you can see. Well, leave it like that. But one thing I'll say, that one way to try to convince you that that has to be true is, imagine taking this area and like this area and adding them and then putting it into a different shape. It would fit perfectly in here if I've gotten the correct height for the average value. So if this right here is FAVG, and you are convinced that the blue area is the same as the red area whenever that height there is FAVG, then F average, then we can quickly get to a formula. Notice the red area should be equal to the blue area. Well, what's the red area? Well, it's this length. Let me do it with red. It's this length. What is that length? Say this was 10 and this was 2. What would the length be? It would be 8. You did 10 minus 2. Well, if I got a B and an A, then this length is B minus A. So the area of the red thing is B minus A, that's the base, times FAVG. And then what's the area under the curve? Well, that's just the integral from a to b of f of x dx. So I can just solve for FAVG and get that the average value of a function from the interval on the interval from a to b is just 1 over b minus a integral a to b of f of x dx. And if you were to Google average value theorem, or you were to look it up in a book, that's the formula you would see. So once again, if you could accept that those areas have to be the same, then we can work it out pretty quickly to get this formula. Now I'm going to work through a couple examples, or just one example. Find the average value of f of x equals root x on the interval from 0 to 9. So I have a little sketch of this right here. I went through 0, 0, 1, 1, 4, 2, and 9, 3. To do this, I'm going to use FAVG equals 1 over b minus a integral from a to b of f of x dx. So a is the 0. Oops. That's A, and this is my B, the 9. So my FAVG is equal to 1 over 9 minus 0, integral 0 to 9 of root x dx. So I'm going to simplify a couple things here. I'm going to get the that it's equal to the 1 over 9 integral from 0 to 9. And I'm going to integrate, so I'm going to write that as x to the half power dx. And then I'm going to do 1 over 9. And then x to the half, if I go up 1 unit from that with power rule, I get 3/2. And then I need to multiply by the reciprocal, 2/3. And it needs to be evaluated from 0 to 9. I'll simplify. That is 2 over 27. And then x to the 3/2. X to the 3/2. This is the power. And this is the root. So that means it is the square root of x cubed. That's the easier way to think about it, but the better way to evaluate it is the square root of x cubed like that. So that's what I'm going to do over here for the 3/2 power. So this is 2 over 27 times root x cubed evaluated from 0 to 9. And that is 2 over 27 times, I'll write it out, square root 9 cubed minus square root 0 cubed. This is just 0. And then this here, square root of 9 is 3. 3 cubed is 27. So I really just get 2 over 27 times 27. These cancel, and I get 2. So that's the average value of this thing right here. And actually, look, if I draw my little red line like we did before, right here, and go like this, you should see that this area up here matches pretty well this area right there. So the area, like basically I could fill in this space right here I could fill in that space right there with an equal amount of area from that space right there. So this integral should be equal to the integral should be equal to the area of this rectangle, and it is. So hopefully you're okay with that, and I'm gonna give you another couple examples in a different video.